Hello everyone, and welcome to today's webinar, Simplifying Container Management with Habitat. My name is Jamie Bright, and I'll be moderating the webinar today. And I'm pleased to introduce today's chef speakers, Ian, Henry, and Michael Ducy. Ian is our Habitat Community Manager, and Michael is our Director of Product Marketing. But before I turn it over to Ian and Michael, I have a couple of housekeeping items to cover quickly. Our recording of this webinar will be available on demand after the live session, accessible through the same link you're using now. We of course hope you'll find value in the information that's presented today, and if you like what you see, we encourage you to share the recorded presentation with your colleagues or followers. We'd also love to hear from you during today's interactive presentation. Ian and Michael will be answering questions at the end of the session, so please feel free to send those along at any time using the Ask a Question tab beneath your presentation screen. Under the Attachments tab, you'll find links to additional resources for this topic, so you can check those out later when you're reviewing the recording. For those of you that are just joining, welcome to today's presentation, Simplifying Container Management with Habitat. Let's go ahead and get started. Ian, why don't you kick us off by telling our audience what we'll be covering here today?
Great. Yeah, and as Jamie mentioned, I am the technical community advocate for Habitat. And for today's webinar, we're going to cover a lot of ground. We're going to try and start off talking up front about the current problems in the world of containers and what it's like to manage containers with a subset of tools that are available now. We're going to then break into an overview of what Habitat is, kind of looking at it from a holistic view, and then we're going to move into describing how Habitat is solving the problems that we've defined in our first section of the webinar. We're going to try and finish up a little bit early so that afterwards we have plenty of time to answer any lingering questions that you might have, and we will go from there. So before we get started, a couple of notes. Most of these links are going to be in the Attachments and Links button on your viewer page. These are some resources for you, whether or not you want to look at them while we're presenting or afterwards. These resources are going to be really good to get you started on everything that's going on in the Habitat community. So we have a Slack team, which is pretty easy to access, slack.habitat.sh. We've got some tutorials out on the Habitat website. And we've also got some links up there for our source code, some blog posts, the forums, which is another great resource for Habitat information. And we've also got a link to the depot, which we're going to talk about during this presentation. And with that, I'm going to hand it over to Michael Ducy.
Thanks, Ian. So the first thing that we want to try and cover are the kind of current pains that we're seeing in the container world. So I tweeted this out at the beginning of the year, and it's funny how much this resonated with people who saw it. And we kind of see this over and over and over again as we talk to customers as they're trying to get started with containers, and we're not picking on Docker in particular, even though that slide says Docker. But there's a huge learning cliff where you have to really start to rethink everything that you've been doing and how you run your operations going forward if you're going to be using a container type model and a more modern infrastructure. Some of the things that we've seen are things like decoupling the application build from the final production ready container. So we see a lot of examples out there, and if you look at Docker files, Docker file examples that you see, a lot of times you're installing things like GCC and Make and other things like that, and then compiling your source code directly inside of the final container that's going to move to production. Hopefully I don't have to explain why that's a bad thing, but we'll get into that a little bit as we get into the meat of why Habitat and why we think Habitat's a better solution for managing containers. The other thing that we see is that the world of containers and the world of kind of microservices architecture really focuses on this idea of immutable infrastructure. So immutable infrastructure is great, but you always have these little things that you need to do for the application and these last mile application config changes that you need to make. The traditional config management tools like Chef and Puppet and Ansible aren't necessarily well suited for an immutable infrastructure type world. So how can you make those config changes, making sure that the container still stays immutable, but the application runtime dynamically at start can pick up those configuration changes that you need? The other thing that you need to try and do is orchestrate the application launch, and also define what the topology is required for a clustering strategy for your application. And you need to have some sort of intelligence to figure out how you actually do that launch in a sane fashion. And that's one thing that Habitat provides, which we'll cover. But if you look at the current solutions on the marketplace of like container orchestration solutions, they're great at getting the containers up and running, but what happens to those containers and the applications inside of those containers once the container has already been launched is really up to the end user. So how can we help customers solve that problem, or help users of container architecture solve that problem with Habitat? And we'll cover that here as well. And then the other thing that you see is, how do you build this idea, or how do you create containers with this idea of a minimum viable operating system? So you want to try and avoid having containers that are very large. You want to have the bare minimum of what you need to actually run the application inside of it. And Habitat provides some interesting solutions to going and giving you the ability to go and build that minimum viable operating system and then layer in your application on top of it. And so with that, I'll hand it back over to Ian, and Ian's going to get into the meat of what we're doing inside of Habitat.
Awesome. Thanks, Michael. Some of these problems are problems that if you're already using containers, you're probably seeing on a daily basis. A lot of the time, those problems are solved by other tools, right? And not just one tool. You've probably got 10 different tools and 10 different services that you're having to run to solve those things in order to have this immutable workflow. So suffice to say that at Chef, we tried for a while to do containers and immutable workflows with Chef, and it was not delightful. Because of that, we now have the Habitat project. And Habitat is about specifically solving for that new paradigm in operations and development. The new paradigm, which should be something that you've all experienced or seen, follows this model for your applications. And what that model looks like in practice is that typically you have a developer who hacks on some application code. Once they've got their application code to a sane place and they've tested it locally, their next step is to plug that into a source code repo. In an ideal world, that source code repo is probably attached to a continuous integration and continuous build system that should generate an artifact from that source code. Once you've got that artifact, that same system is very likely to push that artifact into a repo. Those artifact repos can be things like Nexus, or maybe the Docker Hub if you're working in the container escape. The ideal situation for these modern applications is that we'd like those artifacts to be able to run on anything, whether that's bare metal, inside of a container, a cloud instance, or a VM. Because of that, we've got a problem, which is that doing this is a very, very difficult task. And although we originally believed the containers would allow us to do this very simply, it actually hasn't worked out that way. So Habitat, when we look at it, is specifically about this: optimizing the culture and technology that's around fast, efficient, software-driven applications. And we touch the build, deploy, and management of that application stack, basically the entire life cycle. The general idea here with Habitat is, could we build, deploy, and manage all the software in your enterprise, whether that be cloud or legacy, the exact same way? And Habitat seeks to do that. Our mechanism for doing that always starts with a plan. The plan is we're gonna look at this here in just a second, but the plan is how we prepare software for Habitat. It's about that build step that we saw on the previous slide, right? It provides our build, our configuration, and our runtime hooks all in a single package. Here's a quick snapshot of what a plan looks like. This is a very, very low abstraction, declarative and native shell script, and this is the root of the habitat package. This is how you define your dependencies. It's how you define all of the steps of your build and expose data to any exports that you might have, like a Docker container. And what we're going to do now, I'll hand this over to Ducy, and he can kind of compare for the same type of package in different formats.
So if you look at the exact same, or the official Docker file for creating a Redis-based container, you can see that the first thing that we're going to be doing is that we're going to be declaring what operating system that we're building things from. So what you've noticed in the plan, we were able to declare dependencies in the plan as well. But what we declared as far as dependencies are concerned in the plan are actually the libraries that we need to actually build the software, not the actual operating system. And so this is a little bit different in that we're going from the application stack down to resolve dependencies instead of the traditional method of going from the operating system up. And I'll talk about that in a little bit more. And you can also see at the end of it, so what we end up doing is going and actually doing a make where we're actually going and building the software as well. And you can see that in the plan, we do the exact same thing. So the easiest way to think of the plan is basically, it's the way that you define the application build lifecycle of your particular application, whether that be source code, or it could even be pre-compiled binaries as well if you're not able to build something from source. Let's say, for instance, if you're using something like WebLogic or WebSphere and you need to declare a plan for that particular type of application server.
So the primary difference here that you probably picked out when you were looking at between the plan and looking at the Docker files that we have here is that Habitat provides us a means for building our packages in a different way. We build those packages in what's called a studio, and that studio is a clean room environment. That clean room environment only has what you need to build your package. It will install your dependencies, it's safe, it's audible, and there are multiple types. The difference here between building inside of your final container and building inside of the studio is that when we're done with the studio, what you get is only the things that you need. You're not going to have GCC, you're not going to have make, you're not going to have all of the pork that you have to put into a container to build inside of a container because of our build system in Habitat. Here we got a slide that you can see, excuse me, here we got a slide you can see what a build looks like when we run it inside of the container. It's just two commands, have studio enter, which drops us into our clean room, and build our package name. And doing so outputs everything that we need.
So really what we've done here is that we provided a DSL to describe the application build, and we provided an isolated environment, which is the studio, to build the actual application artifact. And so in doing so, we've actually decoupled how we build the actual application code. In that clean room, as Ian said, you can pull down the dependencies that you need, and then the application will get built, and at the end, you'll end up getting that artifact that you need to go and deploy, whether that artifact's a binary, or if it could be interpreted code as well.
So once you've got those artifacts, we provide a platform called our depot, and the depot stores Habitat packages. It's sort of like apt, yum, Ruby gems, or cpan, and it uses customizable origins for ownership. The depot was built specifically with CI/CD in mind, and in fact, we've actually got on the back end of our depot a continuous build service that will be available in the near future. That continuous build service is going to allow you to link your depot directly to your source code to have Habitat packages built on demand as dependencies are updated. If you haven't seen the depot, here's a quick snapshot of what that depot looks like. We expose a lot of data from your Habitat package. Some of those bits of data that you should be able to see here on the right-hand side are the dependencies of your package and also the transitive dependencies, meaning the dependencies of your dependencies, right? You can also see the version of the package that's available, a checksum, and all of the metadata for the plan options that exist inside of your plan. All Habitat packages are installed by HAB. HAB meaning that's actually the Habitat binary. All of our Habitat subcommands should follow the same easy pattern, which is HAB, noun, verb. So if we actually go back a couple of slides and you look at the studio commands, you can actually see that pattern in practice, which is HAB, noun, verb. HAB studio enter, right? And technically, if you're doing some things like starting a package with Habitat, it follows that same pattern. HAB install would be like HAB install core Redis. Now let's talk briefly about what these Habitat artifacts actually contain. They are obviously the output of your built source code, which is your artifact, but they also contain metadata and config for that package. They're grouped under the /hab directory. So if you were to run hab install core Redis on your machine, you would get a directory path that looks like hab packages core Redis. Now your dependencies, your build dependencies, your config, and binaries are all going to be grouped inside of that directory structure. We use that directory structure to enable you to install different versions of Habitat packages side by side. So the general idea being that, let's say you need version 1 of Redis for one application and version 2 of Redis for another application. The idea here being that if you're running this on a bare metal Linux box, you don't ever have packages that are stepping on each other. That's going to be some full immutability. Here's an example of running a Habitat package install. It's pretty straightforward, right? Hab package install. The next option there is our origin followed by our package name. Habitat packages and the Habitat binary include a supervisor. So when you run a Habitat package under Hab, you're going to get the supervisor. And the best thing about a supervisor, when you're thinking about it, this is not like your standard orchestrator. The supervisors are more like a process supervisor. They're a one-to-one pairing with a PID. So the supervisor is installed automatically when you run a Habitat package. It will keep things running sort of in the way that 12-factor expects your applications to run, right? So if something dies, it's going to keep trying until it succeeds or until you kill that process or that container. The supervisor also allows you to manage your configuration. And we will look at what managing that configuration looks like a little bit later. But the general idea here is that the supervisor will allow you to inject that runtime configuration and reconfigure your packages on the fly should you need to. It allows us to add data we use in our configuration directly through an API. So we also have, as a part of the supervisor, the ability to read in environment configurations. It follows 12-factor style, meaning that you can export environment variables as you start a Habitat package, and those will define various values to the runtime of your package. Excuse me. These environment configurations are a little bit brittle and hard to change. It can be difficult to set a bunch of things at once, and there's no support for complex configuration when you're following these. So if you see this, if you're doing these kinds of things with Docker containers or other containers right now, you're probably used to this 12-factor approach. We provide you the ability to do that the same way with Habitat, but we also provide you what we kind of feel like is a better way, which is like through file configuration. So file configuration is going to be more flexible than static environment variables. It gives you a universal location for where those are stored. and it can be externally enforced. It's still essentially externally managed, but this gives us the ability to have multiple configurations that are super easily audited on a file system, so that you know exactly what is going on inside of your container. It adds a little bit of transparency there. Michael?
Yeah, and an interesting aspect of this is that it also allows you to do encryption. So what Habitat does and the Habitat supervisor allows you to do is basically have communications of these configurations encrypted both in flight and then also at rest. And so what that allows you to do is passwords and other things like that, you know that they're stored securely. And a common method, if you see a lot of 12-factor applications, and if you're setting things in environment variables, well, I think we all know that setting passwords and things like that in environment variables is a bad thing and something that you want to try and avoid. And when, right, exactly, Ian. And so with Habitat, you're able to pass in those secrets that you need. You could also query something like Vault or other key stores and have that information pulled directly from the Habitat supervisor can pull that information directly from a key store as well. So how do you build a mutable infrastructure but allow last mile application config changes? So if you go back to that slide that we had shown you earlier where you actually saw the Habitat package and what was actually built, you'll notice, or if you go into the Habitat repo, so on github.com/habitat-sh, and you'll see a repo called core plans. And if you go and look at any of the core plans, what you'll see in there is a default.toml, and you'll also see a config directory. That default.toml is essentially the baseline configuration for that particular application. And then what will happen is at runtime, the supervisor will take that default toml, parse anything in the config directory, and pass in those configuration variables dynamically at runtime. Now, any changes that you wanted to make, you can actually talk to the supervisor and push those configuration changes down into the actual running environment. So you don't need to go and rebuild the actual application artifact, and you also don't need to go and rebuild a container just because maybe all of a sudden you want to go listen on a different port. Or if you want to do something like key rotation or even password rotation on a regular basis, this makes it very easy to do that without necessarily having to go and rebuild your entire container. So let's talk a little bit more about the supervisor as well. So we talked about this idea of a supervisor. So the supervisor would run in every single container or every single instance that you're running Habitat on. And those supervisors end up forming a ring. So basically, supervisors have peers. They create what's called a service group. So for the actual application that they're running, you can create a service group. So say, you know, depending upon what application or what microservice you're running with that group of containers, they would all be part of the same service group. The other cool thing is those service groups could also identify things as maybe an application server for production, an application server for dev, an application server for staging. Now, within this ring, they talk to one another, and as peers often do, is they often gossip. And so there's a gossip protocol amongst this ring that they're able to pass rumors amongst themselves. And as part of this, those are those configuration changes that you can push into one supervisor. And if you push that configuration change into one supervisor, it will actually push that configuration out into the other supervisors. So that configuration can be dynamic from that perspective. And if you have a set of machines that are clustered together, then you can automatically go and push that change across all those different machines that are running your application.
Yeah, and the supervisors also, aside from forming this kind of gossip mesh, will provide a REST API. That REST API is going to give you the ability to basically easily query from outside of Habitat various bits and pieces of data. It's great for debugging. And what those pieces of data could look like are we provide out of the box a config endpoint that will allow you to see the available configuration from your package. We provide a health endpoint that is a configurable with a run hook that allows you to essentially define what health is for your package, so that you can tell very easily from a REST API whether or not your package is in a good state. We also provide a few other endpoints, including like a package status that will share whether or not your package is up or down or sideways.
And you can also check the health of the ring as well through that API. So if you want to make sure that all the supervisors are communicating correctly, you can see that as well. You can also see if there was a leader-follower election, which he's about to talk about very shortly. You can also query the health of that leader-follower election or the results of that leader-follower election from the REST API.
And that leader-follower election that Ducy is talking about there is almost directly related back to this understanding of topologies. So supervisors have an understanding of topologies, and right now the three topologies that we have support baked into Habitat for are a leader-follower configuration, which is should be pretty straightforward. It's sort of like a MySQL cluster. You may have one lead node and a bunch of follower nodes. The other one that we provide is initializer. So for those of you that have ever used Cassandra DB, that's the best example that I can think of there. You have one node that needs to come up first, and then we don't really care about any of the rest of the nodes. It's just important to get that first one as a seed, and then we attach all the rest. The last that we currently support is a standalone topology, and standalone is exactly what it sounds like. More or less, you can have a bunch of nodes in a mesh that don't care about each other in any kind of meaningful way.
Except for the fact that they want to share configuration with one another.
Right. That's an important distinction to make.
It is.
On top of these topologies, the supervisor also provides update strategies for your packages. Now, this is a little bit of a hand wave right now. I want to reiterate that Habitat is an open source project. It's a very young project that's only been public for a little over 4 months now. So some of these things are not totally in place yet, but I want to kind of discuss where we're going and what we have now so that you get an idea. Right now, the only update strategy that we provide for a ring is all at once. And what that looks like is that your peers in your gossip mesh will essentially determine when they're all ready to do an update, and they'll update themselves at the exact same time, all at the same time. What we are working on right now is providing a couple of other update strategies, one of which is the one at a time, which is more or less a node, all of the nodes across the mesh will decide who's going to go first. That node will go first. It will update itself. It will determine whether or not it's in a healthy state. And then the remaining nodes will say, great, let's decide who goes next, and so on and so forth. And then finally, we want to do it progressive, which is more of like a percentage-based or incremental, so that you get 1 and 2 or 4 or 10 and onwards and upwards from there. What we want is for you to be able to specify these patterns and for the supervisors to be able to execute them without you having to know, the ins and outs of how all of this works.
So kind of a key point on this update strategy is that one interesting thing about Habitat is it doesn't necessarily have to run inside of a container. Habitat can run on VMs and on bare metal systems as well, and you get the exact same functionality, and you get the ability to manage your application build lifecycle, the operational run lifecycle as well in the exact same manner, whether if you're running on a VM, bare metal, or inside of a container. So one of the things we had mentioned earlier, so how do you orchestrate the application launch order and topology required? So we do that, or Habitat does that, through providing this idea of a config-aware, autonomous, self-organizing peers, or also known as supervisors, with built-in topologies for clustering strategies. So once I have this package, what I can do is, so you saw the build process in that screenshot that we showed you earlier. I now have that package. And what I want to do from that package is I want to go and I want to export it. So you may not be using Docker. You might want to use ACI. You might want to use Mesosphere. You might want to also just export the package as a tarball and the package and its dependencies as a tarball. With this post-process package, the post-processing that you can do on packages, that's a lot of piece. what you could do there is export that package as a Docker container, ACI, Mesosphere tarball with the manifest appropriate as well. And inside of that, you're going to get a small, lightweight operating system. And that small, lightweight operating system is going to be just enough to what you need to actually run the Habitat supervisor inside of that container. And then the other thing that you'll get is your application code, the application dependencies as well, all the way down from all of the transient dependencies as well will be included inside of that container. Now let's talk about the idea of bottom to top dependency resolution versus how Habitat actually resolves dependencies. So in that Docker file example that we showed earlier, really what you're doing is you're starting from the bottom and you're layering in the operating system that you need. You layer in any additional libraries that you're going to need. You're going to layer in any config changes that you need. Then you're going to layer in the application libraries that you need. And then finally, you put the application into the actual container and ship it that way. Now, the challenge with that is as the application and the application owner, it's often hard to know all the changes that were applied to that particular system when you go and ship it. And from a security perspective, many of you might have encountered where developers or somebody in your organization, not to pick on developers, has tried to ship a container and they've just pulled an image off a Docker Hub. And so for a lot of customers, a lot of users of containers, especially in an enterprise environment, they can't necessarily just go take a built container off of the internet and then go and actually deploy that out into production. They want to have fine-grained knowledge of what actually went into that container. So Habitat actually provides that by starting with the application. And from that application's plan, it can actually go and resolve all of the libraries and dependencies that that application needs. And then it'll put in a minimized operating system. The advantage is that you know exactly what went into your container. You also know exactly what's configurable about your container because you can go in and query the actual packages themselves. You can also query the container itself to figure out what is actually, what are the things that you can actually change at runtime. And that really goes to this idea of how do you go about moving more to the right and how do you minimize the operating system as much as possible as far as it's concerned as a percent of the container that you're actually shipping. And if you've seen the blog post by Kelsey Hightower where he talks about taking a statically linked Go binary and dropping it into a container, and that's really all that you need to actually run that application inside of a container, we're trying to get you further along that scale of moving towards that model of having almost virtually no operating system and then having the containers primarily concerned being running your application. You can see an example of how you can actually have good traceability as far as what dependencies are being pulled in. If you look at the example that we gave earlier, you see the transient dependencies. Also, if you go to this page on app.habitat.sh, if you look at any of the packages, you'll also see how the actual software was built as well, if you scroll down. Now, if you take an example of something like Node, for example, so all a developer would need to do to actually use the Node runtime is they would have to go in, they would write a plan, and their dependency would be core/node. And that's automatically going to go and pull in Node and any transient dependencies that Node has as well. And the output, the container that's output, or I'm sorry, the container that's exported will have all of those transient dependencies, the Node runtime and the application, as well as the supervisor to manage configuration and also the application run lifecycle. So how do you build containers with a minimum viable operating system? So we do that through allowing applications to declare their runtime dependencies and then resolving those dependencies from the application down to the infrastructure versus how it's been traditionally done for years, resolving those dependencies from the infrastructure level on up. And it really focuses on this idea of building what we call operable application containers. Some common principles that Habitat is designed around, and so this idea of isolated packages and isolated containers. So if you change one aspect of it, you're not going to break your entire fleet. The application artifacts actually being immutable, but even though they're immutable, they give you the base level of configuration that you need. Common interface for checking the health and the status of not only the application itself, but also the supervisors and the ring. The idea that you should rebuild from source, and so that you know where your actual code comes from, and so rebuilding from source all of the dependencies that you need and having that automated build system is really important, we think. And a common packaging technology, no matter if you're running on VMs, no matter if you're running on bare metal, and so forth. And it's really this idea of breaking you free from the runtime and making application developers more worry about actually writing code and not necessarily caring about how things are actually ran. So we call this application automation. So it's this idea that automation travels with the application in that Habitat artifact. And what's really interesting about this is that you can use this not only for containers, but you can also use it for existing applications as well. So you can package up an existing application, like I said earlier. You can take it and run it on any VM, any instance in a cloud provider, or on bare metal systems as well. And you can manage them the exact same way. Or if you're able to do this in your organization, you're able to move more towards a containerized architecture, you can do that as well, and Habitat will work just as well. Ian?
Yeah, the all-important slide here, or one of the ones that I care about a lot. Right now, Habitat is all open source, right? It's licensed under Apache, so it's not something that we can sell to you or would even try to sell to you. We're totally looking for more community members, more people to get into the tools and start hacking on them. And people that want to contribute to our core plans or even contribute things like blog posts. And if you're interested in doing any of that, I'd love to talk to you after the webinar. And and of course, like, you can talk to me on Slack if you'd like. And the link there is the same link that we had at the beginning, right? And that's slack.habitat.sh. I'm on there most of the time. You can also contribute through the forums if you start hacking and you've got a question, you've got the answer to a question that somebody else has. We'd love it if you would post stuff there as well. Awesome.
Great. So I think we're ready for the question and answer section of the presentation. So we do have a couple questions that's come in from the audience. So one of the questions is, and maybe you can take this one, Ian, is there authentication of membership into a supervisor ring?
Yep, so we do have a sort of semblance of authentication. It's not like Kerberos, right? So all of the interactions between peers are going to be, yeah, right. All of the interaction between peers across that gossip layer are going to be synchronously signed transactions. So keys are involved for authenticating into that ring.
So Ian, another question that we have is, how does Habitat compare to things like Kubernetes or Mesos? And do they work with, or does it work with those container orchestration systems, or does it replace aspects of those container orchestration systems?
So both of those things, yeah. So I'll start with the comparison, which is that to clarify, like, Habitat is totally not a scheduler. We're not competing with Kubernetes or Mesosphere. We like to believe that the product actually works really, really well in conjunction with those other tools. So inside of Mesosphere, if you're exporting Docker packages, Docker containers from your Habitat packages, you can manage those the way that you're used to managing if you're already working in that world. I will say that with Kubernetes, there's definitely some crossover on features that are available. So Kubernetes obviously has its own semblance of service discovery, and we also do. So the beautiful thing there being that you can pick and choose how you want to manage these things. If you really like the way that we handle automated deployments, automated configuration updates, you can totally use our stuff. If not, you can still get the benefits of having a super lightweight package that has almost no operating system in it inside of your containers and deploy those with Kubernetes.
Great, thanks, Ian. One other question that's come in. So the example that we gave versus Redis is showing using Debian. Most Docker containers or official Docker images have moved to Alpine Linux. That's giving you a small, lightweight operating system. In those cases, what are the benefits of using something like Habitat?
So in the case of Habitat, our Habitat packages do not use your operating system libraries. The Habitat package, when we look at that Redis plan, if you go back and look at it and look through the dependencies that are listed there, those are other Habitat packages. So those are other pre-compiled artifacts. And what that means is that, like, when you have an atomic, immutable, and isolated Habitat package, it does not touch your underlying operating system at all, which means that all that you actually need to run a Habitat package is a kernel. And that's it. So any of those lightweight operating systems are going to play perfectly well with your Habitat packages, and you're never going to run into a situation where a developer has built a container on their laptop and have delivered it into your Alpine Linux prod environment, and you don't have some weird incorrectly linked library that container is going to try and access.
And I guess the other benefit is you would get the benefits of the supervisor as well inside of that container.
Absolutely.
And another interesting aspect to that I've been discussing with some people is that whenever you use a library from the operating system, you've now coupled yourself to the operating system vendor's release velocity. And if you've ever worked in a shop that has Red Hat Enterprise Linux 5 or 4 boxes, and believe it or not, there are still plenty of organizations that are still running RHEL 4 and RHEL 5. And usually that's because they've linked themselves inside of their application to one of these really, really old libraries in that operating system vendor provides.
Yeah, pretty much anybody who's worked in a Linux landscape has run into that at one point or another, right? It looks like we have one other question that just came in, which is, can we deploy with Nomad? You can absolutely deploy with Nomad. That's a story that I've been kind of hacking on myself recently because I'm very curious about the Nomad tool. I like how lightweight it is as a scheduler. So that's something that I've been playing with. I don't have anything like officially written up on that yet, but suffice to say, yes, you can absolutely deploy with Nomad.
Great. So it looks like that's all the questions that we have. As Ian mentioned, walk through the links, join the Slack team, walk through the tutorials, check out the source code, see how you can contribute. Habitat is actually a project written in Rust as well. So if you have Rust skills or if you want to learn Rust, there's a great opportunity for you to do that. And then also any of the core plans, they're primarily written, well, they're actually all written in Bash. So it's very accessible from that perspective as well. So it's very easy to contribute new plans for different pieces of software. Ian, anything from your perspective you'd like to wrap up with?
Just thanks everybody for coming and listening to us ramble about this, and I just really appreciate it, and I look forward to talking with you all more in Slack and on GitHub and all of the other places. So yeah, with that, I'll actually hand it back to Jamie.
Thanks, Ian, and thanks, Michael. Appreciate all the great information. Thanks to our audience for joining us today. And before you leave, please take a moment to rate this presentation and leave your feedback in the Rate This tab of your viewer screen. We also encourage you to check out the links to additional resources in the Attachments tab of your viewer. Thanks again for your time, and have a wonderful day.